Hello! This video is about refraction, that means, and why it happens. We've been looking at predicting and describing behaviors of light. We've learned that light travels in a straight line. We've learned that light reflects, and when light reflects, the angle of incidence is equal to the angle of reflection. And now we're learning a third behavior of light, that light refracts when it moves from one medium to another medium, when it starts traveling through a different thing. First, some vocabulary. Just like in reflection, we have an incident ray. We can draw a normal line perpendicular to the surface boundary at the point of incidence. And we have a refracted ray. Be careful with the words reflection and refraction, reflected and refracted. And then just like in reflection, we have an angle of incidence measured from the normal to the incident ray. And we have an angle of refraction, again measured from the normal line to the refracted ray. Why does this happen? Let's draw an analogy using a situation some of you may have experienced before. You're at the pool, and you're on the grass next to the pool, but your friend is already in the pool and they're saying, "Hey, come join me, it's so fun in here." And you want to go do a big cannonball off the diving board. So we need to get from where we are, in the bottom left corner of the screen, to the diving board. What is the fastest way to get there? Because we're an impatient, we want to get there quickly. The fastest way is just go in a straight line. You can run across the grass, go do a great cannonball off the diving board. But some of you may know that this actually is not what most pools look like. Most pools have some concrete between the grass and the pool. So does that change our strategy? We still want to get from where we are to the diving board as quickly as possible, but the concrete adds another challenge because there is no running on the concrete. The lifeguard will yell at you and you have to slow down. You can run quickly on the grass, but on the concrete, you have to walk. So does that change our strategy? Is this still the fastest way? Well, probably not. That's a lot of time that you spend on the concrete. Is there a way to get from where you are to the diving board but not be on the concrete, having to walk for as much time? Well, what if we did this? Okay, that's as little time as possible on the concrete. So that's better, but that's still not the fastest way. The fastest way is going to be something like this. A little bit of a compromise. The exact angles, the exact positions are going to depend on the difference between your running speed and your walking speed, but it's a compromise. We spend more time on the grass and less time on the concrete, more time running and less time walking. That gets us overall to the diving board as quickly as possible. This is basically why light refracts. Light travels at different speeds in different media. Generally, the more dense the medium, the slower light travels. All of the particles kind of get in the way of light moving. So in a vacuum where there is nothing, just empty space, that is when light travels the fastest. In air, there are some particles, more particles in water, even more particles in something like glass. Generally, the more dense the medium, the slower light travels. And so just like the grass and the concrete, light is going to bend when it moves from one medium to another, and it's going to travel along the path that requires the least time, so that the light can spend more time moving faster and less time moving slower. Let's look at one more thing about refraction. We talk about light refracting either towards the normal or away from the normal. Let's see what that looks like. In this situation, we have a laser, a light shining from air into water. We can see that the angle of incidence is 30 degrees. Light moves faster in air than it does in water. So light is going to want to spend more time in the air and less time in the water, which means that the angle is going to be smaller in the water, so that it's more like a straight up and down line as we drew it here. The angle of refraction is less than the angle of incidence, so that the light is bending towards the normal line when it moves from a faster medium to a slower medium. But what if we switch the media? Let's have light now going from water into air. The angle of incidence is still 30 degrees, but now the angle of refraction is more than 30 degrees. So when light moves from a medium where it travels slower to a medium where it travels faster, so that light can spend more time traveling faster, in this second diagram on the right, the light will bend away from the normal, so that the angle of refraction is greater than the angle of incidence. That's our quick introduction to refraction. Thanks for watching.